Mean squared deviation. Mean squared deviation is a great name when you're learning how to compute it. However, that's a long name to say, so it's been abbreviated. It's called the variance. Okay, you need to know that they're interchangeable. Variance is the mean squared deviation. Carlton, what do you think mean squared deviation would be? Right, square the deviations, then find the mean or the average of those. Okay, just like it says, you want to make sure you realize that's, if they ask for variance, that's what it's asking for. Square deviations. And find the mean of those. This is so common that it's given a special abbreviation. And it looks like an O, but it's not an O. It's the small letter sigma. It's saying sigma squared, and it just means variance. It's just like the X with the little line over it meant mean. That's all that little sigma with those squares means. It's saying the variance of the data. And then, so let's see, we're doing each data point minus our mean. And we're squaring that. And then we're finding the mean, so after we get the total of all those square deviations, we're gonna have to divide by n. And that's the way you look for it. Again, just meaning the sigma part, the sigma part there saying sum of all our deviations, square deviations divided by n. So in our example, let's see, so we have 2.4 squared. So we have 2.4 squared is 5.76. Negative 1.6 squared is 2.56. 1.4 squared or 14 squared is 196. So 1.96 if I counted for decimals. Negative 1.6 squared. 2.56. 0.6 squared. 2.36. Okay, so same idea. We have all our square deviations, add them together, divide by the number of terms. I believe that comes up to be 2.64. What does that have included in it that we really don't want if we're talking about finding the, if you will, the average deviation from the mean? The squared, right? That's where this next one comes in. We square root it then to take out that squared part. Okay, the root mean square deviation. Now, I've never really seen it called the root mean square deviation other than when it's explained. Because it's so standard, it's called the standard deviation. So standard deviation, it means the same thing. Standard deviation is what you'll commonly hear. So we just basically square root the variance. Because mean square deviation is the variance. Root in front of it, square root the variance. And that's used so commonly that it also has abbreviation, just the sigma now, the little letter sigma. And because we square rooted our variance, but this is sigma squared, square rooted, we just get sigma. by n, and now we're taking the square root of that answer. So in our example, we would take the square root of 2.64, which is about 1.62. If you take a stats class, or if you've taken stats with Mr. Thompson already, you probably talked about standard deviation for population data and standard deviation for sample data. Okay, the book is talking about population standard deviation as a formula. If you took a sample, like if I just asked a sample of this room, let's say most people are making $100 a week, and one person in here is making $1,000 a week. There's a good chance I might not get, if I did a sample of 3, I might not get that one person making 1,000. So then our deviation is really off a little more. This is n minus 1. If you're trying to look at what a sample is and scaling it up to the whole population. But we're not going to look at that too much. Just be aware it's slightly different when you do take that stats class. Right. Now what you see on the back there, this is the actual data from your class combined with the morning class. As far as that test, what the score was. So you can see what the score was and what the frequency was for that score. Or you can find the mean score. Yeah, okay, right, it's basically expected value. Because now we got to account for the frequency. Because this 0, again, just goes 0 plus 1. You can't just go 0 plus 1 plus 2 plus 3, so on. Because 9 people got a 2. Well, that's adding 18 total points to the total class score. So now it's more like expected value. We're accounting for a frequency. So we have 2 people got a score of 0 plus 6 people got a score of 1. So that's 6 points out of the total. 9 people got a score of 2 plus 16 got a score of 3. 14 earned a score of 4. And we had 13 earned a score of 5. 8 had a score of 6. 7 had a score of 3. And 8 had a score of 1. How many total scores did we have? How many total scores were there? 72, right? There was 72. Okay, now if you entered that all in, then I don't want you to spend all your time typing stuff in a calculator. Today was not an explanation part. So our mean, you total all that up, you get 270 divided by 72, which is 3.75. 3.75 is our mean. And by the way, this is actual data. I changed, then on your paper, I think it's scribbled out. I changed one person that had a 2 to a 4, just so we didn't have a weird decimal number, because it was very close to being 3.75. So I guess I changed one person's score. But other than that, it was your real data. Mean absolute deviation, variance. You could use the table to help you, but you wouldn't have to necessarily. What I would do is probably fill in this column. I'd fill in that middle column. So for example here, we'd have 0 minus 3.75. So if I'm doing the mean absolute deviation, let's see, we have two people have the same deviation. The absolute value of negative 3.75 is positive 3.75. So I might just write it in there directly. And then similarly, 1 minus 3.75, that's negative 2.75. So then we have, let's see, 6 people got that. 6 absolute value of negative 2.75 is positive 2.75.
Maybe 2 times negative 3.75.
2 times, it's absolute value.
Oh, okay. Always skip the first column. Going straight to the second.
We're finding the mean absolute deviation. So all I need to do is find the deviations, get the absolute value of them, which is here. I'm saying you don't need to complete this whole table to get the answer. If it helps you to complete the whole table, you can see without, that's fine too. So what I would like you to do is work on the mean absolute deviation, the variance, and then the standard deviation. So find those 3 things, you can check it. Okay, so here again, the mean absolute deviation, we're just taking each frequency times the absolute value of our deviations, dividing it by 72 total scores. Variance, same thing, I would do the frequency times our deviation squared plus the next one, and so on, and then keep that pattern going until we had all of them. I'm not going to write it all out. But then we would divide by 72. So that one came out to be 3.07638. Okay, now I know I'm going to work with it because I'm going to take the square root of it, so we can either store it or we can use our square root with the answer key. Standard deviation 3.7638. The 8's repeating. It's about 1.754. Do you have any questions about how to compute these? I know I skipped over quite a few of the numbers.